Half of the company does 3D visualizations, and the other half does cloud computing stuff. So I'm going to talk mainly about technology. It's a technology stack, not about theming with Diazo specifically. I'm not a front-end person, thankfully. We have good front-end people. Challenge, customer, and how we solved it with Diazo. And we're going to drill down into the technology stack behind it, cloud servers, how we do Diazo deployments, the Toolchain for full stack and front-end developers, and then what we found as the results, TLDR, good stuff, and then a warning. So we're not going to be talking about theming. It's tools for building the front end, tools for building the back end, tools for creating the nginx config and the XSLT module compiled for Diazo, how we deploy it all into AWS in a fault-tolerant manner. So we had a customer come to us and say they're actually a travel site, home exchanges, sort of like Airbnb, but they've been around for about 25 years before the web. They have a website that's about 15 years old out in ASP, and it didn't age particularly well. So they came to us and said, can you help us out? And we said, well, sure. We could rewrite it, and did a prototype in Pyramid that turned out pretty well. But she said, you know, I don't have the budget for that, and I don't have the time to do a proper rewrite. And actually, you know, the application works pretty well. It just doesn't look very good, and we've got a 15-year anniversary coming up. So she was really exasperated, said, you know, can't we just give it a new look and feel? And it seems like a simple request. Like, can't we just make it look better? And no. It sounds kind of snarky, but no. ASP is just like PHP and JSP, where the front-end component is intertwinkled with the logic of the application. There's database calls right in the code. You can't extract a front end from that. And we thought about it. It's like, wait a minute, we've done this. When AWS moved into the cloud, a Drupal team came in and rebuilt it in Drupal. We ran away from that. But they didn't have a theme that was responsive, wouldn't work on mobile at all. So we said, you know, we've got this secret weapon called Diazo, and we can retheme your non-responsive website and make it available to mobile devices. This is about 4 years ago. And www.nasa.gov didn't have to change any of their code or HTML. And it worked beautifully. We were able to extract just the pieces that the customer wanted on the phone and leave all the rest behind. And that worked pretty nice. And I think we were actually serving it directly with Paster. There was not a lot of processing we had to do for that site. Worked well. So our front-end designer worked with a customer who had some ideas for themes and some work that she had done before with another company and said, like, here's what I want it to look like. So our designer gave her a whole new theme. It was responsive, mobile-friendly, shockingly faster than before. Had redundant front end, or our part was redundant high availability, so if one server goes down, the whole site doesn't go down. IPv6 available now. And the ASP app didn't need to change at all. That's a little bit of a lie, because the ASP was actually generating broken code. And some of the pages were generated with 2 body tags. And Diazo, I guess, just picked one, and the one it picked happened to be an empty body tag, so it would just deliver us an empty page. And it took us a long time to figure out until we pawed through this horrible HTML that ASP rendered and said, wait a minute, there's an empty body right there, followed by the full body. So he had to make a couple changes where he had just, you know, invalid code, which browsers will render, but Diazo can't. So that was actually pretty nice. So on the right is the mobile view, and on the left is the normal web view. So I'm going to do a technology drill down. Going from left to right, a client, our user, we took over the name, or repointed the DNS name at our Diazo cluster. Looks up tradetravel.com. It goes to our Diazo cluster. Diazo then grabs the request and forwards it on to the origin server. That comes back with the rendered HTML from the ASP app. Diazo then rethemes it and delivers it back to the customer with a nice new mobile-friendly theme. Works well. Let's drill into the Diazo cluster. We like to do most stuff in AWS these days, and we do not like deploying a single server. Single servers, even in the cloud, will go down. And they'll probably go down at 3 in the morning when you're on vacation. So we always like to deploy a redundant pair so that if one goes down, there's still something up while Amazon figures out, oh, one of your servers went down, I'll bring it back up. Because in Amazon, it takes about 5 minutes to spin up a new instance and get it all running. You don't want the site to be down for 5 minutes. So we always try and deploy in at least a pair. And the nice thing about auto-scaling groups is you can say, you know, when you get a surge in load, if your CPU goes above, say, 50, spin off another instance, and keep launching instances until the average load across the systems goes down below, say, 50%. So that's a pattern we've been doing for a lot of our customers now. We'll do different kinds of components, like in this case, it's Diazo, and another application we're doing image resizing, or we're doing an API gateway. We always deploy in load balanced sets. So each of these instances, basically an EC2 server, is identical, launches from the same image, and grabs the same code. It's running on a T2 micro, which is a very inexpensive Amazon instance. Running Ubuntu, has nginx, which is configured to have a cache and the XSLT engine, and it's got the Diazo rules and themes. The customer request comes in through the load balancer, hits one of the EC2 processors, does the retheming, goes out to the origin, comes back, rethemes, and sends it back to the customer. So drilling down into one of the EC2 instances, basically the only thing it's doing is running nginx. It's running it on port 80 and 443. It's got some redirects, so it redirects 80 to 443, and then it caches everything. It looks in a cache to deliver what the customer requested, if it's got it. Otherwise, it passes that request onto the XSLT engine running on another port, where we've got it configured by being named TTT Diazo. It's got its theme defined in a directory, and it's got all of its theme compiled down to an XSL spreadsheet. That Diazo then reaches out to the TTT origin server, the ASP application. So it's actually, we've got a fairly complicated stack of things to build and deploy because we like to do as much automation as possible. So we're using AWS Cloudformation to define what the AWS resources are, and we layer on top of that Troposphere, more on that in a second. We use Make to hide the complexity of some of the tool chain from front-end and back-end developers. We use Buildout, of course, to build everything, Circle CI to do CI/CD, and Code Deploy to push it out to AWS. We'll take each one of these briefly. But Troposphere is a Python library that wraps around CloudFormation. CloudFormation is a AWS product that allows you to find all your cloud resources in a JSON or now YAML file. This allows you to create your technology stack. You can get quite complicated and deploy it, and it deploys successfully, or it doesn't deploy and it rolls it back. Once deployed, it's really nice because you can then make a change. Let's say we need to change the scaling value, that we want to scale at 40% instead of 50%. We make a change to the CloudFormation template and then redeploy it, and CloudFormation on Amazon just tweaks the values that it needs to, and if it needs to kill a server and relaunch it, it does that. It's a fantastic way of producing producing infrastructure from code, and that code is checked in with your regular application code, so it's repeatable, it's findable, and it grows with your application. But it's a pain in the ass to write in JSON, so Troposphere allows us to write everything in Python. It allows us to do loops, allows us to do .ini file configurations of our infrastructure. And we have two different cloud environments set up, one for staging and one for production, that are slightly different. Staging only has one server, production has that pair. We've learned the hard way that we shouldn't define our network infrastructure and our application infrastructure in the same file. We need to be able to separate it, so we have two different files. The net infrastructure Troposphere file builds our VPC, it's a virtual private cloud, spans two different basically Amazon data centers or availability zones, defines the rules for allowing us to come in through SSH, defines the load balancers, routing, subnets, and basic access policies into the cloud resources. And the app infrastructure defines the EC2 instance size we want, T2 micro, defines the auto-scaling criteria, 50%, and when you see you're about 50%, you trigger this alarm. When that alarm fires, you do this event. The event is to scale up by 1. When it's below 40%, you scale down by 1, and so on and so forth. So first we deploy the network infrastructure, then we deploy the application infrastructure. We really only had to do this once or twice. You know, once we got it defined, it just stays there. Since then, we've added other applications to the server, so we've added some other things to the basic infrastructure. But it's really nice to be able to define all this hairy infrastructure and all these connections between things in code. Trying to do it through console is just asking for trouble, and it's not something you can repeat. So there's a number of build-out tools and all this other stuff underneath the covers, but our front-end developer isn't a Python developer. So we've come up with some nice tools, and we just wrap everything in make. I'm an old-school C programmer, and make is a nice way of abstracting or hiding a lot of these things with some simple targets. So we can just say make clean, or make build, or make run, and this will do all the things you need. It'll create a virtual environment, and then it will run build out, and then like if you then run, and then it will actually run paster for you, and then the developer can go look and see what it looks like. For full stack developers, we have another make target, make clean, make full stack run, and so on. And that actually builds libxml and all the other stuff, fun stuff you need, and it runs the build out to build Python, and it runs it on your local Mac, so you can test out whether your nginx is working properly. We've also got targets for production, which we don't tend to run, but we'll see later how they're used. And we've also, because we're developing on Mac, but we're deploying to Ubuntu, we've built a Docker image that we then build and deploy to, so we can test whether our nginx is actually building properly on Docker. That's been really valuable for making sure that we don't screw something up before we deploy it to staging or production. So we just have if you say make help, it tells you what you can do. It's a nice reminder. Every time I forget, I just say make help. It's a handy thing. It's just a wrapper, but it's easier than writing scripts. And it understands all the dependencies that, like, to run, you have to build. To build, you may have to do something else. You have to get dependencies. So that kind of stuff's hidden. So, of course, we use Buildout. And when you say Buildout, it looks for Buildout CFG file. In our case, all we've done is have that extend a Buildout base. Buildout base. Somebody's tapping the phone. Buildout base defines all the parts, all the myriad parts that we have for this. libxml, XSLT, compiles the Diazo theme, builds nginx. It patches nginx with, to allow it to properly process HTML when HTML may not be exact. And then for the full stack developers, it builds all that stuff and deploys it onto the Mac. And for production, it does the exact same thing, and then it adds nginx log rotation, which we want in our servers. Nginx config is it's fairly hairy in this case. We have two different targets for nginx, one for local development, and then one for the staging and production environments that are slightly different. Again, it creates a server that listens on 80 and 443 that redirects DNS aliases. In this case, like tradetotravel.com goes to luxuryhomeexchanges.com. It's all about SEO for the client. And it also creates a cache, which is what handles all the requests initially. And that cache then goes through to the XSLT engine, which runs Diazo. It also defines the rules for XSLT, living on port 8888, and enables the XSLT HTML parser, and defines what the origin server is in the proxy pass directive. It says go back to that ASP origin server, and it defines directories or paths that we shouldn't theme. We shouldn't be theming images, fonts, scripts, and we found out a little bit too late that it was accidentally theming the site XML file, and not good for SEO. We use Circle CI for our commercial customers. It's a really nice CI service. It's inexpensive. You define what happens when your code is committed in a circle.yaml file. And when you commit code, it invokes Circle CI, wakes up and says, okay, I see you've got code in there. I'm going to go follow the Circle YAML file. It'll, again, use the make file, Docker build. It goes and builds everything. And if that works fine, it'll then run the tox and integration tests for us. And if those pass, it then invokes Amazon CodeDeploy, only if the tests pass, and if it's on branch develop, like we've merged our feature branch down to develop, it pushes all the changes to CodeDeploy in the staging environment, and we let the customer then preview it there, and if she says, okay, good to go, then we merge the code down to the master branch. Circle CI again fires and tells Amazon CodeDeploy to deploy it to our production environment, which has 2 servers. And CodeDeploy is smart enough that if you have more than one server, it'll deploy it to one, and then check and see if it's happy, and then deploy it to the other, instead of deploying it all at one time and propagating a bug that takes your site down. Code deploy to me feels a little bit primitive. Amazon tends to come out with a product that is a really good idea, but maybe not fully formed yet, but you start using it, and then next year they'll add some more features and add some more features based on user feedback. So there's some things missing, but basically it follows 5 steps. When code deploy is targeted, it runs the 5 steps in order, and we've just named them the same thing Amazon does. So the first thing it does is it kills nginx, and then the before install does an apt-get install for all the things we need and creates virtual environment. Now, if that's already been done by a previous code deploy, then this step takes almost no time. After install, the install is actually installing the code. So after install, we do the make production build. Again, we're heavily using the targets in this make file, not just for developers, but for all our automation. And after the code is built, we run the production target, which fires up nginx with the XSLT and cache. And then the last thing code deploy does, it does a validate service, and we have a simple production test that checks a couple of the URLs to make sure they're okay. Now again, code deploy it could be smarter. It doesn't have a way, if the validation step fails, to roll back. It just sends a signal that says your deployment failed, and now what? We could probably handle that better by having in the first step, before killing nginx, copying, say, the entire directory, the entire deployment directory over to a temporary place, then doing all the install, and then after validation, if the validation fails, copy the previously working thing back and restart it. But it hasn't been a problem for us yet. Because we've been able to test on stage before we go to production, we have never had any worries that we'd accidentally deploy something broken to production. So the tool chains have really helped. It is pretty complicated because we're trying to do a fair amount of automation, but we don't have to worry about it because we can just say, make this, make that. We define an infrastructure with code. We can update that very easily. Docker has been essential for us testing out nginx to make sure it would actually work on staging, because there is a difference between the way things work on Mac and on Ubuntu. Circle CI allows us it's great that our front-end developer can just commit the code and watch it deploy to stage and call it the customer and say, take a look now, how do you like it? And code deploy, well, it's, I think, a little bit feature deprived. It means that we don't have to. For other systems, we actually just kill servers and have them launch new code with a fresh server. This deploys to existing running servers, which is much faster, assuming the servers are already up and running, which is 99% of the time. So performance is pretty good. Running locally on a local Docker server is pretty fast. Running in production is astoundingly fast. We did some benchmarks on it because the customer was really worried that having this retheming engine in front of their application server would be slower, but we did a bunch of tests, and it's actually faster on most pages than going directly to the origin server serving ASP. I think it's because we're using a cache to serve most of the content, or it's just that that must be it. I mean, there's no other reason because the origin server is the weakest link in the chain. I was also surprised that the compiled XSLT is consuming almost no CPU. Even on these tiny instances, T2 micros that cost like $5 or $10 a month, there's almost no CPU load being used by it, and that was a real thrill. We might be able to do smaller servers. It's a joy. It costs so little to run this service for her. The compiled theme is under a meg. I don't know if that's big or small. It seems kind of big. The customer wanted a lot of customization, so it's probably bigger than most people's themes. Unfortunately, running under Paster for the local front-end developer ain't fast. It's like 5 seconds to load a page. I think it's because we've got a fairly complicated theme, hundreds of files that have to be recompiled when Paster is run in development mode so that the front-end developer can see changes immediately. And unfortunately, the legacy backend is a single server. It's a single point of failure. If that goes down, the whole app is dead, but we can't control that. So the final thing is a warning. Diazo is developed by the Plone community, and it's intended mainly to retheme content living on an origin server. You make your changes on the origin server. That's why it's called the origin server. But Diazo allows you to create any amount of content in your theme. You can have a About Us page. You can have original content. And our customers asked us, hey, can we just put a new paragraph there? Or I just want to do that. Or my admin's out, can you just do it on your site? And we've foolishly said yes too many times. So now we own part of the content, and the customer owns part of the content. And if the customer wants to change the content we own, we have to make the change. Then we have to do a deploy because it's running on a production server. We should not have said yes. We should say no, and we should have explained to her why this is a really bad idea. So it's just a warning. Diazo gives you a lot of power. It gives you the power to shoot yourself in the foot. Generally, though, really, really happy, and I think Diazo is a secret weapon. It's not known, I think, outside of the Plone community, but we've done a number of pitches to folks where they have, especially at like government sites or large enterprise sites, they may have a dozen different web apps. Like they may have an issue tracking system or a workflow system or some other systems that they want to tie together and seem as one application. Diazo can do that by retheming multiple disparate backends with the same common theme. Or maybe the company is going through rebranding, but they also have an ASP or JSP or PHP site where they can't change the code without busting all the logic. I think Diazo is a real secret weapon that you can use on a lot of projects for people. So we've cloned our customers' stuff with all the tools in there that you can look at. I haven't gotten it quite up on GitHub, but that URL is going to be where it goes live. If you have any questions, feel free to reach out, and I can do a little demo. The QR code is for the GitHub repo if you don't want to type it in. I'll put these slides up on SlideShare and tweet out the location after the talk. So let's try a little demo. So make, yep. Okay, this actually will take less than 5. So make clean run. This builds it locally without nginx and uses paster to do the running of it. And so our front-end developer doesn't have to worry about Buildout in Python or anything. She just make run, make build, and it does the thing. Should take just another minute. There we are. So what I've done is I've created, instead of using the customer's theme and customer's backend, I've just taken our company site and done, because I'm not a front-end person, I've just done the minimum thing I could do. I replaced our corporate logo with the Plone conference logo. So it's not, let's do IT service. It's not exactly, that's actually not too, well, yeah, you can see it loading. It's not exactly the fastest running under paster, but it's, it's not too bad for development. But it's a lot snappier when compiled down into XSLT, running in Docker or running in production servers. So that's it. Any questions?